equations in case you missed class last week when we went over it. So a one-step equation is an equation that involves one operation, as in you have to use one operation to isolate the variable or solve for the variable. Remember, with all equations, the key is understanding how to use inverse operations. So an inverse operation is simply an operation that will undo an operation. So if you look at the table, you'll see that addition and subtraction will undo each other, and multiplication and division will undo each other. Now, when I'm looking at any equation, one-step equations included, I always ask myself, what is happening to the variable? So in this case, I am adding 3 to a. So I'm adding 3 to the variable. So after you ask yourself the question and answer the question, what are you doing to the variable? You need to do the opposite thing to that variable. So if I'm adding 3 to a, in this scenario, I have to subtract 3 from a. So I'm going to subtract 3 from a. In order to keep the equation balanced, I also have to subtract 3 from the other side. So after I do that, I have 3's go away, canceled, and I have a equals 11. Now I can check that by plugging that 11 back in. 3 plus 11 equals 14. This works perfectly fine. All right, let's do another one. Here's another one-step addition problem. So I'm going to ask myself, what is happening to the variable? In this case, the variable, I'm adding 7 to it. The opposite of adding 7 is subtracting 7. So I'm going to go ahead and subtract 7 from both sides. In this case, x equals 15. Now, let's check our work. Plug that 15 back in for x. So I'll show you on this one. I'm not going to show you all of them for time, but in this one I will show you. 15 plus 7 equals 22. If that's true, then I know 15 is correct. 15 plus 7 is indeed 22. That works, therefore that is my answer. All right, let's look at some subtraction problems here. So you'll notice on 3, two things are happening here that's a little weird. First off is that w is actually a negative value. It's a negative w. So there's one trick I can use to make that positive. Before I even try to get rid of that 5, I can just go ahead and make w positive by adding w to both sides. Now remember, when you're solving an equation, as long as you keep it balanced by doing the same operation, it's still the same equation. So I'm going to go ahead and add w to both sides. That will leave me with 15 equals 17 plus w. Now I have a positive variable. Okay, now I can do the following. Now I can go ahead and subtract 17 from both sides. Okay, so 5 minus 17 is negative 12. Negative 12 equals w. Now I can check that by plugging negative 12 back in. So 5 minus negative 12 equals 17. Now remember, when you're subtracting a negative value, this is actually an addition problem because you're getting rid of a negative. So 5 minus negative 12 is actually 5 plus 12. 5 plus 12 is indeed 17, which means our answer of negative 12 equals w, or we could rewrite it this way, is correct. All right, let's look at question 4. This is almost something I would consider a two-step equation, just because you have to do multiple steps to solve it. Same scenario here. If I want to make that positive, I can just add j to both sides. Now, the negative j is canceled out by the positive j. I'm left with negative 16 on the left and negative 6 plus j on the right side. Now I'm going to ask myself, what's happening to j? Well, I'm adding negative 6. Now remember, adding a negative 6 is something the same as subtracting. So in order to get rid of that negative value, I just add 6 to both sides. So remember, when you have the sign in front of a constant, it's really the same thing as subtraction. So this cancels out. Negative 16 plus 6 is negative 10. So I think j equals negative 10. Let's check. So I have negative 10 minus 16 equals negative 6. Okay, now this one looks kind of funny and it can be confusing. If I have a negative 10, that really means this is positive 10, because negative 1 times negative 10 is positive 10. So really what I have is 10 minus 16. 10 minus 16 is negative 6. Negative 6 equals negative 6. My answer is correct. All right, let's move on to another kind of problem. Question 5. For question 5, I have 5 minus negative y. Now, I could go ahead and move the y around, but I really don't have to, because we know if I'm subtracting a negative value, I really have 5 plus y equals 18. Because remember, if you're subtracting a negative value, it's the same as adding. So now I have negative 5 minus 5. Use inverse operations. So this is addition. I'm adding 5, so I'm going to subtract 5. This cancels out. Y equals 18 minus 5 is 13. Now let's check this one. So 5 minus negative 13. Why am I putting a negative in there? Because remember, y is 13. This negative sign is just in front of it. So I still have to put that in like that. Okay, so remember, I'm going to say that one more time. I'm only putting the 13 in for y. The reason I'm leaving the negative sign there is because there was a negative sign in the original equation. So if I'm going to check it, I need to include that. Now I'm left with a scenario where I'm actually adding 5 plus 13. 5 plus 13 is 18. 18 equals 18. This checks out. It works. All right. Let's try the next problem. Okay, so adding a negative value is the same as subtracting. So m plus negative 9 is the same as m minus 9. Okay? So think about it. If you're adding a negative, it's the same as subtracting a positive. So I'm just going to write that as m minus 9. It looks cleaner. It's easy to understand. I'm going to add 9 to both sides to get rid of the negative 9. M equals 27. So let's check. 27 plus negative 9 equals 18. Okay, so remember this is the same as subtracting 9. 27 minus 9 equals 18. 18 equals 18. It works. All right, let's move on to multiplication. So in this case, the parentheses around here is indicating multiplication. So right now, if I'm asking myself the question, what's happening to s, I can say it's being multiplied by 7. The opposite of multiplying by 7 is to divide by 7. So I'm going to divide both sides by 7. That cancels out. 56 divided by 7 is 8. Okay, let's check. Let's do a mental check. 7 times 8 is indeed 56. This works. All right. Over here, you just see it displayed a little differently. So there's no parentheses, but if you see a coefficient or a number in front of a variable right next to a variable, that indicates multiplication. So in this case, I'm multiplying b by 4. So I need to divide both sides by 4 to get the b by itself. That cancels out. 24 divided by 4 is 6. B equals 6. Let's do a mental check. 4 times 6 is 24. Good, it works. All right, now let's move on to division. Okay, so in this case, t is being divided by 5. Okay, remember, ask yourself what's happening to the variable. T is being divided by 5. The opposite of dividing is multiplying. So I'm going to multiply both sides by 5. These 5s cancel out. I'm left with t. 65 times 5. Well, I know 5 times 60 is 300, and 5 times 5 is 25. So 300 plus 25 is 325. Okay. 325 divided by 5 is indeed 65, so that works. Okay, same thing here. I'm dividing k by 11. The opposite of dividing something by 11 is multiplying, so I'm going to multiply both sides by 11. That cancels out. K equals 11 times 11 is 121. Now let's do some mental math. 121 divided by 11 is 11. That indeed works. All right, we're going to continue working on multiple step equations, two-step equations and whatnot for a while here. So hopefully you guys understand the basics of using inverse operations to isolate a variable. As always, if you have questions, feel free to email me.